Good morning, students. Now, in today's video, that is part 23 of error analysis, we will discuss about combination of errors and the problem or numericals based on combination of errors. So, first of all, look the meaning of combination of error. What is the meaning of combination of error? As it is clear from the name, combination of error means whatever the physical quantities which are involved in the experiment, if these physical quantities are measured individually, then suppose I am taking an example. Suppose any physical quantity you are measuring and that physical quantity is z. Suppose that physical quantity is z and that z is dependent upon v, and that v is some physical quantities and I is some physical quantity, and the z is the combination of these two physical quantities. So we can write from here that z is equal to v into I. Now for the performance of experiment, for knowing the value of z, first of all we have to know the value of v and we have to know the value of I. Both the physical quantities, the values or the measured values of v and I should be in our knowledge. Now we are measuring individually. First of all we are measuring v, and after that we are going to measure I. Now what are the possible errors? Suppose v, in the measurement of v we had got the error that is plus minus delta v, that is the absolute error in v, and we had expressed the term v with its error. Similarly we had got the error in I, that is plus minus delta I. Means whatever the values we had calculated through experiment, we had written in the form of error, Now this is the individual measurement, this is the measured value for v, this is the measured value for I. Now how the error, that is del v and del I, is going to be propagated in our result, that is z. How it is going to be propagated in z. So the method to find the combination of two errors or propagation of error with the formula involved in our experimental calculation is called as the combination of error. So there are certain rules for that. There are certain rules to define the combination of error in the formula used for the calculation of some physical quantities. So in this topic we will discuss about that rules. What are the rules which are involved for the calculation of combination of error or the propagation of combination of error, because the result of experiment obtained by doing mathematical operations on several measurements, the final error depends not only upon the errors in individual measurement but also on the nature of mathematical operation. Whatever the mathematical operation, suppose here there is v upon I, there is also certain mathematical operations where there is the error propagating like rho, suppose rho v d a, such type of formula. Suppose this quantity is y. So here for the calculation of y we are using this mathematical formula: error in a, error in v, error in d, error in a. How these errors are propagating, how the combination of errors are propagating in our result for obtaining y. So these rules we must have to know for the proper knowledge of error or propagation of error. So we are going to discuss about that rules which are involved for the combination or propagation of error. So let us start. first rule, that is A. First one is error in sum. Error in sum. Error in sum means to say that if there are two physical quantities which are just added, then how the error is propagating in the error is propagating in the sum, that is z. So we had supposed, let two quantities which are to be added, quantities A and B. These are two quantities A and B which have to be added to get the sum. Delta A and delta B are absolute errors in A and B. In A and B measurement of A and B, delta A and delta B are absolute errors. So measured value of A is what? Measured value of A. The measured value of A can be written as A plus minus delta A, and measured value of B, measured value of B is equal to B plus minus delta B. Look at here, A and B are, so we had supposed any physical quantity A and B are any physical quantities over which the sum of A and B is depending, and the error in A is delta A and error in B is delta B. They are absolute individual errors in these two physical quantities. So A can be expressed as A plus minus delta A and B can be expressed as B plus minus delta B. Now let Z is equal to A plus B. We had supposed Z is equal to A plus B, or Z plus minus delta Z. That is error in the sum, that is delta Z is equal to A plus minus delta A plus B plus minus delta B. That is error in A and error in B. Since we had included the error along with A, error along with B, so we had included error in the sum plus minus delta Z. Now Z plus minus delta Z is equal to A plus B plus minus delta A plus delta B, or Z plus minus delta Z. You can write, we had supposed Z is equal to A plus B, so we can write it as Z plus minus delta A plus delta B. Now we can cancel it out, and we can say that plus minus delta Z is equal to plus minus del A plus del B. It can be cancelled out, and we can say that delta Z is equal to delta A plus delta B. Means if the experimental calculation consists of sum of two physical quantities, then in that case the error in the final result will be just arithmetically added up, that is delta Z is equal to delta A plus delta B. So maximum possible error maximum possible error in sum is the sum of individual errors. Sum of individual errors, that is sum of error in A and error in B. Now this is the case for error in case of sum, when there are sum of two physical quantities. Now error in case of difference. Error in case of difference. Second thing is error in difference. Error in difference. If Z denotes the difference of two physical quantities, then Z plus minus delta Z, that is error in difference, is equal to A plus minus delta A minus B plus minus delta B, and it can be written as Z plus minus delta Z is equal to A minus B plus minus delta A plus delta B, plus minus delta A plus delta B. Now we had supposed Z as A minus B, so we can write here A minus B, at the place of A minus B we can write it as Z plus minus delta A plus delta B. Now it will be cancelled out and we can write it as delta Z plus minus delta A plus delta B. It get cancelled out and we will write the result delta Z is equal to delta A plus delta B. Means in case of difference also, what we had observed, in case of difference also, the error in the final result is the sum of, in the case of difference also, the error in the final result is the sum of error in individual physical quantities, that is A and B. So error in Z is equal to error in A plus error in B, similar as in the first case, that is error in case of sum. And in this case also maximum possible error, in this case also, the maximum error in the difference, the maximum error in difference is the sum of individual is the sum of individual errors. Now next, this is the case of, we had discussed about the error in case of sum, error in case of difference. Now we will discuss about error in product or quotient. Error in product or quotient. Error in product or quotient. We will discuss about error in product or quotient. So again here, let two quantities, we had supposed two quantities A and B, delta A and delta B are the corresponding absolute delta A and delta B are the corresponding absolute errors in the measurement of the physical quantity A and in the measurement of physical quantities B. Delta A and delta B are the corresponding absolute error. Then measured value of A, measured value of A is equal to A plus minus delta A, and measured value of B is equal to B plus minus delta B. This is whole story. As before we had discussed, the same story is here. Now, in case of product, let Z is equal to first case we are taking the case of product. The first Z is equal to A into B. This is the product when two physical quantities are in the form of products of that quantities, which is giving a new physical quantity. Means a physical quantity can be expressed as the product of two physical quantities, just like V into I. So we can write it as Z plus minus delta dash, that is error in product, is equal to A plus minus delta A into B plus minus delta B. A plus minus delta A into B plus minus delta B, or Z plus minus delta Z is equal to, we can write it as AB plus minus B delta A plus minus A delta B plus minus delta A into delta B. Look at here, A into B, AB, फिर B into delta A, फिर delta B into A, then delta A. We had associative property we had applied here, and by the associative property we had done the product of these two errors. Now dividing both sides, dividing both sides by Z. On dividing both sides by Z, on dividing both sides by Z, so look at here what will happen on dividing both sides by Z. What expression we had written? Look at here, Z plus minus delta Z AB plus minus B delta A plus minus A delta B plus minus delta A into delta B. And when we are going to divide it by Z, we will have to divide it by AB, and it is given as 1 plus minus delta Z upon Z is equal to 1 plus minus delta A upon A plus minus delta B upon B plus minus delta A into delta B upon AB. Now look at here, delta A and delta B. This quantity is very small, very small. Why we are taking it as very small? Because error in A, it is small. Suppose 3.003, 3.004, 3 plus 0. जैसे we are writing 3 plus or minus 0.03. For example, I am taking. Similarly, B, in B it is also small, 2 0.00, So these are the errors, and these errors are very small. And since this delta A and delta B are very small, it means to say that the product of delta A and delta B, their products delta A and delta B, it is also very small. It is also very small. So, and when a very small quantity, suppose 0.0003 is divided by 5, then a very small quantity we will get. So this is a very small quantity. So this is a very small quantity, and since it is a very small quantity, so it is ignored. So it is ignored. So it is very small, and since it is very small, so here delta A into delta B upon AB, it can be ignored. We can ignore it. It can be ignored, and the final result is 1 plus minus delta Z upon Z is equal to 1 plus minus delta A upon A plus minus delta B upon B, because we had ignored this quantity because it is infinitely small, very infinitesimally very small, so we had ignored it. And what we had got, it can be cancelled out, and we had got Z is equal to plus minus A delta A upon A plus minus delta B upon B. Now taking common plus minus, by taking plus minus common, by taking plus minus common, what we had got, delta Z upon Z equal to plus minus delta A upon A plus delta B upon B. It will be cancelled out, and it is delta Z upon Z is equal to delta A upon A plus delta B upon B. So what we had obtained here in case of product, the relative error in the product is the sum of relative error in the measured physical quantity A and B. It is just the sum of relative error in the measurement of Z, A and B respectively. Means relative error in the product is the sum of relative error in the measured quantity A and B, del A upon A plus del B upon B. Now we will discuss the second part. I think you all had cleared it. If this thing is clear to you all, very simple things which I am discussing. Now that is error in case of quotient. Second one is error in terms of quotient. So for quotient we can write it as Z is equal to A upon B. Z is equal to A upon B. From here we can write Z plus minus delta Z, that is error in quotient, A plus minus delta A upon B plus minus delta B. And from here we can write it as Z plus minus delta Z is equal to, taking A common, 1 plus minus delta A upon B into 1 plus minus delta B upon B. Now we can write it as Z plus minus delta Z, that is equal to A upon B, 1 plus minus delta A upon A into 1 plus minus delta B upon B power minus 1. Clear? And now it can be written as A upon B, we can write it as Z, and it is equal to plus minus delta A upon A, and here we can apply binomial theorem. I'm writing here and I will explain it. So by applying binomial theorem, this power is going to be multiplied with here and it will become plus minus delta B upon B. What is binomial theorem? Suppose 1 plus x to the power n, and if x is less than 1, if x is less than 1, then we can write it as 1 plus n into x. If x is less than 1. How x? So here also it is 1 plus minus x, and x is less than 1 because 0.1 upon 5. This value. This is very small quantity upon big quantity. Obviously its value will be less than 1. So the power, the power of this factor is going to be multiplied with this quantity, and we will get the value 1 plus minus delta A upon A into 1 plus minus delta B upon B. We had applied here this condition. This is called as binomial theorem. Binomial theorem. In detail about it you will study in your maths book. Here it is sufficient for your knowledge. So by binomial theorem we had expressed the power is going to be multiplied here, just like that. Now simply multiplying over here, what we are doing, we are simply multiplying, and what we will get Z 1 plus minus delta A upon A plus minus delta B upon B plus minus delta A into delta B upon AB. Look at here. This multiplied by this multiplied by this multiplied by this quantity we will get. As we had discussed in the previous case, in case of multiplication, this quantity is very small divided by a big quantity. It will be infinitesimally small. It will be very small, infinitesimally small. Since it is infinitesimally small, so it can be ignored. And what will we get? Z 1 plus minus delta A upon A plus minus delta B upon B. And from here, what we will get? Z plus minus delta Z is equal to Z 1 plus minus delta A upon A plus minus delta B upon B. Now dividing here, we will get 1 plus minus delta Z upon Z is equal to 1 plus minus delta A upon A plus minus delta B upon B. It will be cancelled out, and here also we are going to get del Z upon Z is equal to del A upon A plus del B upon B. Means the error in the case of quotient, error in the case of division is similar as in the case of product, and the relative error in the quotient or relative error in the product is the sum of individual relative error in the quantities which are divided or which are being multiplied. So it is the algebraic sum of individual relative error in each measured value which will be carried to the product or the quotient. So when two quantities are multiplied or divided, the relative error in the product or quotient is the sum of relative error in the quantities to be multiplied or divided. So no need to write it here. It is clear. You are looking sum of relative errors. It is the sum of relative errors. Now the third case is error due to the power of measured quantity. Error due to the power of measured quantity. Measured quantity. Error due to the power of measured quantity. Let there be a quantity. Let there be a quantity A. Delta A is the absolute. Delta A is the absolute error. Delta is the absolute error in the measured quantity. Now we have to express it in the form of power. So we will take it as Z is equal to A square. Suppose we have taken the simple power, Z is equal to A square. So Z plus minus delta Z can be written as A plus minus, that is error in A, absolute error in A, delta A whole square. Now mathematically A plus B the whole square, we will get A square plus delta A square plus minus 2 delta A into A. Clear? Now square of very small term, square of very small term, so square of very small term, so it is infinitely small, infinitesimally small, so it can be delta A square can be ignored. It can be ignored and we will get the value what? We will get the value Z plus minus delta Z is equal to A square plus minus twice A delta A. Now we had supposed A square as Z, so it can be cancelled out and it can be written as delta Z is equal to plus minus 2A delta A. Get cancelled out and delta Z is equal to twice A delta A. Delta Z is equal to, now dividing both sides by Z, dividing both sides by Z, del Z upon Z is equal to twice A delta A upon Z means A square. A to A cancel out and it will become delta A upon A. Means what we had seen that the error in the square of any physical quantity, the relative error in that quantity is the power multiplied by the relative error in that quantity. So in general form we can say that if Z is equal to A power n in general, we can write it as if Z is equal to given quantity power n, then delta Z upon Z is equal to n delta A upon A. The power is going to be multiplied. The power is going to be multiplied with the relative error in the measured quantity. Clear? So the result, relative error in the result is the power multiplied by the relative error in the measured quantity. Clear? This is error in the form of power in the measured quantity. If error, transmission of or communication or propagation of error in case of power in the measured quantity. Now we are taking the last one, general expression. General expression. General expression we are taking. And in case of general expression, if z is equal to a power b, b power p, and c power r, then what will happen? Then del z upon z is equal to p. Since power is here, so it is multiplied. Look at here, all things are clear. All whatever the error we had studied in case of sum, difference, multiplication, division is going to be clear. So p power delta a. Okay. Now here what you are seeing, here there is the product, and product between a per power p, and so it will be added p del b upon b, and it is divided by c. So in case of division, the relative error is also going to add it. We had studied power is multiplied, r delta c upon c. Clear? This is the relative error in the expression. So this is all about the propagation of errors. Now we are going to solve a question related to this. Look at here. Look at the question. The percentage error in the measurement, the percentage error in the measurement of mass and speed are 2% and 3% respectively. 2% and 3% respectively. How much will be the maximum error in the estimate of kinetic energy obtained by measuring mass and speed. So look at the question, read the question. Percentage error in the measurement of mass and speed. Mass and speed, the percentage error is given, that is 2% and 3% respectively. It is given. Percentage error I had discussed, del m upon m and del v upon v multiplied by 100 is the percentage error. How much will be the maximum error in the estimate of kinetic energy? You know that kinetic energy, that is k is equal to half mv square. So we have to calculate del k upon k, because k is equal to half mv square, and based on the propagation of errors, applying the concept we had studied in the propagation of error, as well as the errors, absolute error or percentage error we had studied. On the basis of that, we are going to solve this question. Look at the question, how we are proceeding with the question, and try to solve the rest of the questions on the basis of that. E is equal to, that is kinetic energy, I am representing E is equal to half mv square. So we can write it as del E upon E, and it is equal to This is constant, so it is of our no meaning. Del m upon m, since it is multiplication, so added power is going to be multiplied del v upon v. Clear to all? So del E upon E, that is relative error in the measurement of energy, 2%. Del m upon m, 2 upon 100 plus 2 into del V upon V, 3%. So 3 upon 100. Now we will get 8 upon 100. This is the error, relative error. This is the relative error. And if this relative error is multiplied by 100, then we will get the percentage error. So percentage error in the estimate of kinetic energy, that is del E upon E into 100, and it is equal to 8 upon 100 into 100, and it is equal to 8%. This is the percentage error in the measurement of kinetic energy. Right, one another question, try to solve it, and I will discuss it in the next class. A physical quantity P is related to four quantities AQ, B squared under root C into D. Percentage error in A, B, C. Percentage error in A, it is given as 1%. Percentage error in B, it is given as 3%. Percentage error in C, it is given as 4%. And percentage error in D, it is given as 2%. Respectively, it is given. Then what is the percentage error? You have to calculate percentage error in P. Percentage error in P is, you have to calculate the percentage error in P. Try to solve it. Answer is 13%. Try to solve it, very easy question. Power is multiplied, and this under root C means 1 by 2. Try to solve it. In next class I will discuss about this, and after that the last topic of this chapter, that is significant figure and rounding off, we will discuss in the next video. So that's all for today, students. Thank you and have a nice day.